Okay, so we're looking at applications of vectors in geometry, proving things. So the first thing is what properties are important, and these are the properties that are important. If two vectors are equal, then the lines representing them are equal in length and are parallel. If two vectors have the same magnitude, then they must have equal lengths. If A equals lambda B, then A and B are parallel. They're different lengths, but they're parallel to each other. And the last one is if two vectors have a point in common. Okay, they don't have a point in common, but if two vectors have a point in common, then they are the same line, and that's called collinear. So here, there's no point in common, but when one vector and another vector have a point in common, then they must be on the same line. Okay, so that's important things to know for geometry. Okay, so what we're looking at are 3 examples over the next 3 pages, and these are ones you may not have ever seen before, but we're going to use vectors to prove it. So the first one is prove that the line segment, that's a singular, line segment joining the midpoint of 2 sides of a triangle is parallel to the third and half its length. So I've got a triangle ABC, and P is mid of AB and Q is mid of BC. So what it's trying to prove is that PQ equals half of AC. That's what we're trying to prove. Okay, we don't prove it by actually drawing it up, we're actually going to prove it. Okay, so let's try it by defining a few things. So let A be equal to A, so that vector there is A, and let BC equal B, so that vector is B. Now you could have CB equals B, but it doesn't really matter. And from that, okay, so that's vector A, that's vector B. So if AB equals A, then AP equals PB, and that's the more important one, PB, and that equals a half of A. And if BC equals B, that's not there, so B there, then BQ, so from B to Q will be half of B. Now, how do we get from P to Q? Well, to get from P to Q, we go up and then down. Okay, so PQ equals PB plus BQ. PB is half of an A, and BQ equals a half of a B. So I've got a half of A plus B. And the question is, how do you get from A to C? Well, to get from A to C, you go up and you go down. So AC equals AB plus BC, which is A plus B. And so now we've got our proof. Therefore, PQ equals a half of AC, because we've got half the formula. Okay, that's A plus B, that's A plus B, we've got half. It's half its length and it's parallel, so that's QED. Okay, copy that, come across. Okay, so next one is prove that when the midpoints of a rectangle are joined, then a parallelogram is formed. So basically what we've got is, if I join that, and that, then I've got that. So before you start, think about what you're trying to prove in terms of vectors, and write those statements down and see if you've got the same as me in a sec. Okay, what we need to prove is that AB, so from A to B is the same as D to C, and we need to prove that B to C is the same as A to D. So make sure you get that the letters in the right positions. Just make sure that's a C. So B to C is the same as A to D. Now I'll only do one of them, because once you've done one, the second one will be the same. Will be the same proof. Okay. So what we're going to do is let PQ equal A, and let PS equals B. Okay? And then let's see what we can get. If we're going to go from A to B, how do I get there? If I'm going to go from A to B, I've got to go, now don't forget these are midpoints, so these distances are the same. Okay, so if I'm going to go from A to B, I've got to go halfway from SP, and then halfway of PQ. Okay, so I'm going to go A to B, so I'm going to go half up, halfway, and then halfway. Now PS is B, so SP equals minus B, so I've got minus a half of B, and then PQ is in the right direction. So I've got a half of A minus B. Okay. Now, I'm trying to prove that that equals that. So, how do you get from D to C? How do you get from D to C? Well, I go DR. Oh, sorry, I go half of DR plus RC, and DR is a half of SR, and RC is a half of RQ. Okay, so S to R is the same as P to Q, so I've got half of A, and R to Q is the same, so RQ is the same as SP, so I've got plus minus a half of B, which is a half of A minus B, so therefore AB equals DC. And similarly, you can show that that equals that, which you would have to do for the whole proof. Okay. We've got one more example of a geometry proof, and then there'll be an exercise on Moodle. Okay, now this one is going to use the idea of dot products that we did in one of the later videos. And I'm just getting my notes ready. Okay, so again, this is one you've known for a while in different ways. You actually did it in circle geometry. We're trying to prove that the angle in a semicircle is a right angle. Okay, so if we can prove in dot products, if we can prove that AB and AC equals 0, then we have then we'd have AB is perpendicular. Okay, so that's what we're trying to prove. If we can use the dot product to prove that it gets 0, then we have perpendicular lines. Okay, so let's have a look. I've got two vectors, OA and OB. Now A and B aren't the same vector because they're going in different directions. Okay, they might have the same length, but they're not the same vector. So we've got AB. If I want to go from, if I want to go from A to B, it doesn't make you go B to A, but I'm going to go A to B. When if I go from A to B, then I've got to go AO, and then I go OB, which means I've got minus A, and then I've got positive B. Now, if I want to go from A to C, I could go from C to A, but it doesn't matter. If I want to go from A to C, okay, I've got to go, if I want to go down, I've got to go backwards, and then I go forwards. So I go AO plus OC. Okay. So I've got minus A again. Now this is where you've got two vectors in opposite directions. So if that's B, then that will be minus B, because it's the same size, it's just the opposite direction. Okay, so I've got minus A minus B. So now we do the product. So I've got AB times AC equals minus A plus B minus A minus B, and then I just use expanding. Actually, in my notes, I'm going to change that to C. Really sorry. Actually, I'll keep going with minus B and just see what happens. Otherwise, I'll have to start the video again. So I've got a minus times a minus, so I've got A times A minus A times B is minus A times B, then minus A times B minus B times B. Those cancel out. So I end up with A times A minus B times B, which is going to be A squared, well, so equals A squared minus B squared. Okay. But the magnitude of A equals the magnitude of B, so end up with 0 as my answer. Okay, and therefore AB is perpendicular to AC. So just back here, so they've got I get A squared minus B squared, but the magnitude of A equals the magnitude of B. So then I end up with the same numbers subtracted. So I end up with 0, and then end up with perpendiculars. Okay, and that's the last one of that video. Okay, there'll be a worksheet to work on. Bye.